What if I told you that everything you thought you knew about life in the universe was about to change? Is this the moment? Is this the discovery we've all been waiting for? For years, we've heard whispers and seen tantalizing hints. The strange methane plumes, the complex organic molecules found by the Curiosity rover, even that controversial meteorite from Antarctica decades ago. Each one was a flare of excitement that eventually faded. But this is different. NASA just released an announcement that I have to say, after covering space exploration for years, feels different. It feels heavier, more substantial. The Perseverance Rover on Mars has found what a top NASA official is calling the clearest sign of life that we've ever found on Mars. This isn't just another headline about water ice or a chemical signature that could be debated away. This is a potential fossil, a tangible, preserved remnant of an alien biology. So what exactly did our robotic geologist on the red planet find? And could this finally be the proof of extraterrestrial life we've dreamed of? Let's get into it, because this story is truly incredible. For decades, we've been sending probes and rovers to Mars. It's become our cosmic backyard, a world we've mapped, drilled, and listened to. From the first grainy images of the Viking landers in the 70s to the tireless treks of Spirit and Opportunity, each mission has peeled back a layer of the mystery. But underneath it all, one profound question has driven every single mission. Are we alone? The Perseverance Rover, the most advanced astrobiology lab we've ever sent to another world, landed in Jezero crater in 2021 specifically to answer that question. Its mission wasn't just to follow the water, but to seek the signs of life itself. And the location wasn't an accident. Billions of years ago, Jezero wasn't the dry, dusty, windswept crater we see today. Scientists have proven it was a massive, tranquil lake, possibly dozens of miles across, fed by a powerful river that carved a delta, a fan of sediment rich in clay and minerals. Here on Earth, river deltas are fantastic at trapping and preserving signs of life. As water slows down, it drops fine-grained mud and silt. This material gently buries whatever is living at the bottom, creating a low-oxygen environment that protects delicate organic matter from decay. That mud and silt is the perfect medium for turning microscopic organisms into fossils. So scientists made a multi-billion-dollar bet that if life ever existed on Mars, this ancient dried-up lake bed was the place to find its ghost. And last year, while exploring that ancient river valley, Perseverance hit what I can only call the Astrobiological jackpot. It drilled a core sample from an arrowhead-shaped rock named Chayava Falls. That sample, a fragile cylinder of rock no bigger than a piece of chalk, is now safely sealed in a pristine titanium tube on the Martian surface. It's been named Sapphire Canyon, and it is the entire reason the global scientific community is buzzing with a level of excitement I haven't seen in my career. So it's just a rock, right? Wrong. When the rover's cameras, acting as the eyes for scientists back on Earth, zoomed in, they saw something fascinating. Strange, colorful patterns they nicknamed poppy seeds, and more prominently, these striking leopard spots. Now, my first thought was, maybe it's just weird erosion or a strange collection of minerals. Mars is a geologically complex world. But when the rover analyzed these spots with its advanced instruments, a suite of lasers and spectrometers called Sherlock and Watson, the data that came back must have set off alarms in labs across the world. The spots are packed with a very specific and telling combination of minerals, vivianite and greigite. Now, I know those are just complicated names, but think of it like this. Here on Earth, finding those two minerals together in ancient sediment is a massive clue for geobiologists. Vivianite is a phosphate mineral that often forms around decaying organic matter, trapping the phosphorus that is a key building block of life. It's in our DNA. Greigite is an iron sulfide mineral that can be directly produced by the metabolism of certain sulfur-eating microbes. Finding them together, intertwined with organic carbon, it's like finding a smoke detector, a footprint, and a half-eaten sandwich at a crime scene. Individually, they're interesting. Together, they tell a powerful story. They are literally a potential fingerprint of life. The theory that the science team has put forward is just mind-blowing. The idea is that billions of years ago, when water filled Jezero crater, the muddy lake bed was teeming with microscopic life. These Martian microbes wouldn't have been breathing oxygen or sunbathing. Instead, like life found in the deepest, darkest parts of Earth's oceans, they might have survived through chemosynthesis, basically eating chemicals to get energy. They could have used the organic compounds sulfur and phosphorus in the rock as fuel. The leopard spots, these patches of vivianite and greigite, could be the mineral waste products they left behind, their fossilized metabolic signature. As lead scientist Joel Horowitz said, this chemical mix could have been a rich source of energy for microbial metabolisms. It's a complete self-contained ecosystem preserved in stone for 3.5 billion years. But, and I cannot stress this enough, we have to be scientifically rigorous. This is the bedrock of science. NASA is being very careful, calling this a potential biosignature. That's the key phrase. It means it looks like life, it smells like life, but we can't definitively rule out a non-biological origin. Yet. Extraordinary claims require extraordinary evidence. So, could these spots have formed without life? The paper published in the prestigious journal Nature, after a full year of intense peer review, explores this. And yes, it's theoretically possible. But here's the catch, and for me, this is the most compelling piece of evidence. The known non-biological ways to create these mineral patterns usually require very specific and violent conditions, like very high temperatures from a volcanic event, or extremely acidic, battery acid-like conditions. And the rover's detailed analysis of the surrounding rock shows no evidence of either. The rocks were never cooked or drenched in acid. They were formed in a relatively benign, water-rich environment. So, when you rule out the most likely non-living explanation, what are you left with? It's like Occam's razor. The simplest explanation that fits all the data is likely the correct one. As acting NASA Administrator Sean Duffy said, after a full year of top scientists trying to find another way, they can't find another explanation. That single quote gives me chills. So, what's the next step? How do we get from potential to the absolute proof that would rewrite our textbooks? Well, the rover has done all it can. Its instruments are incredible, but they are limited. To get the final world-changing answer, we absolutely have to get that Sapphire Canyon sample back to Earth. Here, in our most advanced labs, we can analyze it with instruments the size of a room, electron microscopes that could search for cellular structures, mass spectrometers that can analyze isotopic ratios for the telltale signs of biology. This is technology far too complex to ever send to Mars. But here's the dramatic and frankly frustrating twist. The Mars Sample Return Mission, the multi-billion-dollar international plan with NASA and the European Space Agency to bring these samples home, is in trouble. It's facing serious budget cuts and uncertainty. It is absolutely heartbreaking to think that we could be on the verge of the greatest discovery in the history of science, and we might fumble it because of budget arguments here on Earth. It's like finding a locked treasure chest with the secrets of the universe inside, and then deciding the key is too expensive to make. The answer could be right there, waiting for us. So this is where we stand, on the knife's edge of discovery. We are closer than we have ever been. We have the clearest, most compelling, multifaceted piece of evidence for life beyond Earth sitting in a tiny, sterile tube 300 million miles away. It is not confirmed, but every single piece of the puzzle, the ancient lakebed location, the specific chemistry, the unique mineral combination, and the lack of good alternative explanations, points in a profoundly exciting direction. This is more than just a science story. A confirmation of life on Mars would reshape humanity's place in the cosmos. It would touch on our philosophy, our religions, our very identity. It would mean that life isn't a one-off miracle that happened in a single corner of the cosmos, but that the universe might be teeming with it, just waiting to be found. So I have to ask you, what do you think? After hearing all the evidence, are these leopard spots just a bizarre geological quirk, a cosmic coincidence, or are we looking at the fossilized remains of ancient Martians? I truly want to know your thoughts, so leave them down in the comments. If your mind is as blown as mine is right now, please hit that like button and share this video. This is a conversation everyone should be a part of. Subscribe for more updates on our journey to the stars and ring that notification bell because if and when they confirm this, you'll want to know immediately. Thanks for watching. See you in the cosmos.